Hey everyone, this is Udit again from TechSpark, bringing you another session covering data engineering question and answers. And in today's session, we're going to talk about Python collections or different Python data structures. So as usual, I'm going to start off with a brief introduction of myself. I have been working in this domain for almost 9 years with various projects and involved in creating data pipelines both on-premise and on cloud for several clients. I train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. So do reach out to us to know more. Okay, so in the world of data engineering, and when you will be dealing with uh, large volume of data, obviously you're going to be using APIs like PySpark or Hive to process the data, to store the data, or for real time, or for the real time ones, it should be Kafka or the structure streaming, right? But in some cases, there would be instances where you would need to eventually handle some of the data or some of the portion or even column values using UDF. UDF is a Python or PySpark customized function. Okay, so I'm gonna cover that in one of the later sessions. But the fact of the matter is, you may need to deal with the Python raw code over there. You would be dealing with, say, arrays or list or data structures that you need some knowledge of in order to use them even without the PySpark, because there are some processing that you may require which is not provided by the PySpark SQL functions. In those cases, you may need to take a help of Python different data structure functions. Okay, if I talk about Lambda, which is one of the most popular phenomena, or one of the most popular strategy to iterate over different elements in a data structure. So we have seen the usage of them in the RDDs when we were working with the Spark RDDs, and it is similar to that of raw Python code. I mean, if we have any Python collection that we want to iterate and process each and every element, then we can use Lambda or comprehension or different other functions that we are provided with. Okay, so let's take a look at the different collections that we have. So we have the two kinds of collections. One is the index space, the other one is non-indexed or key value pair. Okay, so if I talk about the index space, so we have three different collections. First is the list, second is the tuple, third is the set. And the reason they are being indexed is because each and every element can be accessed using their position. Now Python has zero based index, meaning the first position would be zero, then one, two, and that's how it goes instead of like one, two, three. And so if I want to, so for those people who have no idea about collections, who have not worked with any programming language, so to speak, because collection is not like Python exclusive, it's there in Java, .NET, or any other Scala, any other programming language for that matter. So those who don't have any idea about the collection, so it's basically as the name suggests, right? So I do have an accumulation of different sets of data or different sets of how should I put it, variables, be it like integer or strings, into one single stack. So that is a collection. So if I talk about a list, it means, I mean, in layman terms, a list means some form of a accumulation, or some form of a accumulated or a total collection of things that needs to be that needs to be considered. So similarly in Python also, the list means it's a collection of similar kind of data. It could be integer or string or anything. Okay, so similarly, the tuple and the set are the same things, and these are all indexed, meaning the first element in the list is the zeroth index, the second element is the first index, and that's how it goes. So, just for the sake of understanding, just hold this thought that how lists, tuple, and set look like. But when I'll be going into the actual demo, when I'll be showcasing you with some examples of lists, tuple, and set, you will understand what I'm trying to say. Okay, so let's talk about list first. This is the widely used collection in Python. That is the most popular one, and it's the easiest one to access, as it has like n number of functions or methods that I can do. So processing with the numbers or processing with any data which are contained in list is much easier than that of tuple or set. So list is ordered, it's mutable, it allows duplicate values and indexed. Okay, let's go one by one. What is ordered? So it maintains the order of elements, meaning, so if I have a list and I'm going to add some elements into the list, in which, I mean, the order in which I'm adding when I try to show them, when I try to display the whole list, in that case, I'll see those elements are in the same order in which I have put them. So that means the list is ordered, so it doesn't lose the original order. Okay, mutable means, I mean, as the name suggests, can be changed after creation. So it can be altered, it can be modified. I can simply add or remove any elements from the list. So that's one feature. Third one is it can allow duplicate values as well. So I can have a list which can have, say, duplicate integer, maybe more than once, two, three, four, n number of times. Similarly, goes with the string values. So that's one thing. And the last one is index. As I said, right, I can simply fetch any column element, sorry, any element in the collection using the using the position number. So that's all about list. Okay, now coming to the tuple. So tuple or tuple, so that is also ordered. I mean, it maintains the original order, the way, in the sequential manner that I have put the elements in. Then it is immutable. Okay, the second thing, now there's a difference between the list and the tuple. It is, the list was mutable, I could add or remove any element as and when I want. But the tuple is, it is immutable, means once I create a tuple, it cannot be changed. So if you remember, when I was covering the RDD part, all the data structures that were being created as part of the RDD, those were tuples. Those were neither list or sets. Okay, and the reason being, RDD is immutable. You cannot change an RDD. You can create another RDD out of the previous RDD, but you cannot edit or modify the actual RDD. Okay, so that's one, I mean, characteristic of tuple. The third one is it also allows duplicate values, like list, and the fourth one is index, meaning I can pick any position, or I can try to show any element using the position number. Okay, that is the 0, 1, 2, 3. Now third comes the set. So set is, first of all, it's way different than the list and tuple. If you see the characteristics, you will understand. First, it is unordered. It doesn't maintain the order in which I will be adding the element. Second, it is mutable, though. There is this one similarity with list, is that I can add or remove any element from a set. Third one is it will never contain a duplicate. Okay, so that's the main highlight of set. Using, I mean, the significance of using the set is that it doesn't contain any duplicate value. Say if I have a list and I know it can contain, it may or may not contain duplicate values. So in that case, if I want to have a unique set of collections and I have the list, I can convert it to set. So set will automatically remove the duplicate values and it will contain only the unique ones. Okay. Third one, sorry, the last one is unindexed. So there is one difference. So there's another one difference between the list and the tuple. You might be wondering that I put the set under the index-based collection slide, but the reason being is these three collections, however, they look almost the same. I mean, it is like a single number or single element collection, okay, which is kind of different than the key value paired or the dictionary. When I'll be going in, you'll understand. Okay, so the set is an index, meaning that you cannot simply pick any character or any element from the collection by providing its position. And if you just look at the number 1 point, that is for the set, it is unordered, right? So this is the main reason why it is unindexed. Because if it is unindexed, sorry, if it is unordered, meaning it doesn't hold the actual order of how the data have been put or populated. In that case, if I don't know the actual position in which they are all in the set, then how can I simply just fetch any element using the position, right? Since it is not ordered, I don't know the order of the data, so I cannot pick any position and try to showcase the value. Okay, so this is about all the linear sets. Linear, I won't call it linear, I would say like single element collections. So list, tuple, and set. And the last one, the different than the other three, is the dictionary. So in case of dictionary, it is unordered. It was unordered before Python 3.6, and now in the later versions, it is ordered. It is mutable. I can change or modify the element of a list, and it won't have any duplicate keys. Okay, it's not saying it won't have duplicate values or duplicate element, but duplicate keys. Okay, the reason being is the fourth point, that it is a key value pairs. And if I talk about indexing over here, the index term can be used for the keys. So it will have each and every element as a key value pair. So I have one single example over here is that I'm using a MyDict dictionary where the name, age, city. So these are the keys, and accordingly the values are for the name, the Alice is the attribute or the value. For the age, value is 25. For the key city, the value is New York. So you can understand this name Alice is one single element in this dictionary. For second one, it is age 24. So it's the combination of the key and the value pair. So that constitutes the each and every element in the dictionary. Okay, and say if I want to access any value for any particular key, I can simply just call upon the key from the dictionary name like this, or I can use the get function as well. So it will give me the value, that is the access over here. Sorry, that is the Alice. So over here, since I'm picking the key name, so it will obviously show Alice. Had it been like age, in that case, it would pick 25 because that's the value of it. So that's all about the theory portion. Now let me go to the Jupyter notebook and show you some examples. All right, so now I have opened a Jupyter notebook terminal. To install any Jupyter notebook, all you have to do is just install Anaconda, or you can install Jupyter notebook separately, and then you just the Python environment will be automatically created for you. You don't need to do anything manually. So over here, you just go to new and you just click on notebook. So I think I already have one created notebook over here. I'm going to use this one. Sorry, this is not, it's not a new one. So let me create a new notebook over here. So by default, it will have a name like untitled. So if I want to change the name, I can do that over here. Let me just put some. Okay, so my notebook is up and ready. So let me first create a list. To create a list, what you have to do, you just need to give third bracket or this kind of parenthesis. Okay, so this squared parenthesis, and then you have to put some element. So suppose I'm putting this 1, 2, 3, 4, 5, 6, comma 6. Okay, so this is a list. This is a representation of a list. So you can assign it to any variable. Suppose I'm calling it as A. So A contains the value of a list which holds these elements. These are 1, 2, 3, 4, 5, 6. So this is one way. Okay, and if I, so what are the functions that list can have? Now if I want to say I want to add a new element to the list, okay, so I want to add 7. In that case, I will simply do a dot append is the function to add one any element in the list, and then after this I have to call a. So remember one thing, after appending I have to call in the list again. So if I just try to run this one, this will show nothing. If I try to print this, it doesn't work like that. Okay, it is showing me none. So list appending is a function that happens in place. In place means that I don't have to assign this to another variable. Okay, I will simply call the append function, and afterwards if I call the list again, it will show me the new list. So now you can see the 7 is also added, right? So this is one. So this is one of the functions that we generally use to add any element to the list. So if I want to remove, so now A has 1, 2, 3, 7, right? So I want to remove 7. Okay, now we are back to the original list 1, 2, 3, 4, 5, 6. So just see over here. First, my list I create as 1, 2, 3, 4, 5, 6. Then I append the 7th element. Then the A would be now 1, 2, 3, 4, 5, 6, 7. So if I call in A over here, it would show me. Okay, let me just print it and put a print over here. See the difference. Now after appending 7, I print A, it is 1, 2, 3, 4, 5, 6, 7. Then I remove 7, then print A, it is 1, 2, 3, 4, 5, 6. Okay. So these are a couple of functions that we can use to add or remove any element. Now I was talking about indexing, right? So now each and every element in the list has a position. So first one starting on the 0, then this 2 is at 1, then it is 2, 3. That's how it goes. Basically 1 to 6 will have 0 to 5 indexes. So if I try to get the first index, so if I try to get the first element, I have to put the 0th position because that's where the first element would be setting. So it is 1, right? So similarly, if I want to last one, in that case there are two ways I can do it. I know the length of the list is 5, so sorry, length of the list is 6. So for the last one, for any collection, if I want to pick the last element, in that case I have to do -1. If I put -1, in that case, it will pick me the last one. Otherwise, if I know how many elements are there, so over here 6, so that means the last one would be 5, right? It is starting from 0, 0, 1, 2, 3, 4, 5. So that is the sixth one. So if I put 5 as well, it will show me the same result, that is the 6. Okay, so this is what the index means. And if you want to check all the indexes, all you have to do is just using a for loop, you can just check it. Okay, now this is the index. I have shown you that it is mutable. We can add, edit. It is indexed, and there are some other functions as well. I can use the sort function. If I use sort a, it will simply, okay, sort is not defined. Is it a dot sort? And if I call a, yeah, sorry, it was a, I mean the dot sort, not the sort wrapper function. So over here, obviously the numbers are already sorted, so no need to use those. Let me just jumble up the numbers and see how it works. Okay, now let me sort this one. So 1, 2, 3, 4, 4, 11. So it has been sorted ascendingly. So these are the functions. So these are the methods we can use to process with a list. And now let's come into set. So set, as I mentioned, right? So it is somewhat like list, but there are some typical. Sorry, let's talk about tuple first. So tuple is much like list. The only difference is that tuple is immutable, right? So for to define any tuple, what I have to do, instead of like the square brackets, I have to use this parenthesis, the first bracket. Okay, so I can use the same numbers. Let me put some duplicate in. Okay, and this is my set. So I'll just gonna put B over here. Okay, I'm sorry. I have been calling it set, but it is tuple. Okay, so this is a tuple. So you can see the visual representation, the differences between that. The list will have the square parentheses, whereas the tuple will have this kind of parentheses. Okay, so if I want to now the thing is I can use the index over here as well to access the elements. That is the one. If I want to get the last element, in that case I can simply put -1. But what if I want to add or remove any element? It doesn't have that feature. Okay, if I use b dot append say 7, then it will fail. It will say tuple object has no attribute append. So I cannot add or remove for that matter any element inside a tuple. So that's the feature of it, right? Tuple is absolutely immutable. Now coming to the set. So set, as I told you, right, the set is unordered, and set doesn't contain any duplicate value, right? So if I use the same collection, that is the tuple over here, the only difference would be for set, it is this curly braces for the set. So there are three typical visual representation of each and every collection, right? The list has this squared parenthesis, the tuple has this first bracket, and this one has the curly braces. So that's how a set is defined. Okay, so now if I try to print the C, or if I just see this, if I just try to display the C, let's see how the values are coming up. Okay, so now you see the difference, right? Over here there were two duplicates for 4 and 6. Now they are gone. So that is the speciality of set, is that it totally removes the duplicate values from the collection, and it will only show the unique values. Similarly, it cannot be indexed. If I try to do something like C0 or C1, it would say set object is not subscriptable. The reason is it is unordered. So it is not indexed. You cannot simply put any position and try to look into it. However, if you do try to want to look at it, you can just use the for loop. So I'm going to use for I in C, print C. So using a for loop, I can see, okay, some, not C, it is I. Yeah, so this is how I can iterate over a set and I can see each and every individual element. All right. So these are the main differences between a list, tuple, and set. So as you can see, the list has almost all the features, apart from the fact that it, if you try to remove the duplicates, you have to do your own custom processing. But it can add or even remove any value. You can, use an index to check one any value. It is mutable, it is ordered, it is indexed. It has all the features that you require. So that is the reason this is most popular amongst all the other collections. Second one is the tuple. Tuple is similar to set. The only difference is it is mutable. So you cannot add or edit anything. So usually the RDDs in the Spark API, they use the tuple because the that structure is immutable and the RDD itself is immutable, right? So this is the reason tuple is used in the API Spark. And the third one is set. For set, the main characteristics is it will remove the duplicates, right? Now let's talk about the last one, which is the dictionary. So dictionary is quite different from the others. It will hold for each element at least two values. That is the key and the pair value. So I will create a dictionary over here. Let me put the same references. Name was over there Alice, and then the key age. And for this one, I'll be using an integer value that is 25. Okay. And what was the other? Okay, city is New York. So I'm gonna put city as New York. Now, to iterate over each and every value in the dictionary, all you have to do is just use a for loop and use the key value pairs in d dot items. Okay, just have a look at, I'm gonna print k, and also I'm gonna print the v, the value. Okay, just take a look at this code snippet. So D is the dictionary that I've created, right? So D dot items will give me the key value pairs for each and every element. All right. So if I want to iterate over element, obviously I need to iterate like separately the keys and the values. So k comma v is mean that k is the key. So you can put, instead of kv, you can put ij or mn, whatever, ab, anything. That's an arbitrary term. Okay. The fact of the matter is d dot items, if you try to iterate over the items of the dictionary, in that case it will return you for each and every element two item or two elements, so to speak. That is the key and the value. So if I were to print each and every key and value of the element, in that case, it will show me like this. This is the first key, then the name, and then the value, that is Alice. For the second one, then the key is age, the value is 25, and so on. So if you do want to put them in the single line, that is also possible. Just put print comma v, k comma v, and then you can see them in the single line. All right. So that's how you can. So that's how you can literally call each and every element in dictionary. If you want, you can, if you want to check the keys and the values in dictionary, so there are different other methods as well. You can just put d dot keys and it will show you the keys. Okay, so these are the keys, right? Name, age, and city. And similarly, if you want to check the values, so that is also there, big value. So the fact of the matter is, if you want to check any value based on the position is not here, right? It is not indexed as such, but you can use the key in order to get any value. So suppose I want to check what is the value for age, right? So in that case, two ways I can do it. I can either put this way, which will give me 25, or there is a get method. Get method will also uh, get me the value of age. The only difference is the if there is no as such key exist, in that case it won't throw any error, it will simply return none. So if I use say um, What should I put? Say salary, okay, over here, which is a key is not present. So if I do d dot get salary, so it will return nothing. I mean, you'll see empty, but at least if you try to print, it will simply return a none type. But similarly, instead of get function, if you try to do it in a brace way, that is using the square brackets, so this will throw an error because this key is not present. So it will say key error salary. So that's one kind of like a DR strategy, is that if you know that your key might not be present, then you can use the get. And if you see that it is returning null, it means the key is not present. Okay, so these are the operations that you can use using the collections. And how do we, and there are separate, I mean several other collection functions, like for example, if you want to iterate over them and do some any processing, you can define the function and you can put it into map. And there is, if you want to create a new collection based on the older collection, say suppose I have this list, okay, and each and every element I want to multiplied by 2, or each and every, multiplied by 3, or whatever may be the function, then I can simply do that using one liner comprehensions as well. So I will cover this in the later session. So for the moment, this is just a beginner one, and hope you all understood the different data collections and how they're used in the world of data engineering, or when we are using Python API. So yeah, so that's all about it from this session. Just do reach out to us if you need any sort of guidance or need any more disclosure about our course. So our course can, I mean, cover everything. It covers all the data engineering aspects such as Spark, Hadoop, Hive, AWS. It will cover Python basic data structures as well as the Pandas library. So that's one more thing that you need to be familiar with as well. So just do reach out to us in case of any query. Uh, so I'm signing off for this session. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.